Now we're gonna find the limit of this function, and the first thing you want to do when you find the limit of this function is you want to plug in your 1. Well, when you plug in 1, it becomes 1 over 0 minus 1 over 0. You can't do that because 1 over 0 is undefined, minus undefined, it's just, you can't do that. So we're gonna have to play with this function until it actually becomes something that's real. So by combining these two fractions, you'll be able to come up with a real number. So we're going to do that. We're going to combine the fractions. So the limit as x approaches 1 becomes x times ln x minus x minus 1 over x minus 1 ln x. And so now we've combined it. Now when you plug in your 1, it just becomes 0 over 0. So we get 0 over 0, and now we can apply L'Hospital's rule. And so this is a product and this is just regular. So we're going to do the product first. So x ln x, and we want to take the derivative of that. So it says f prime g plus g prime f. So we're going to take the derivative of f, which is x, so this just becomes 1. And we're going to leave g, which is ln x. We're going to add the derivative of ln x, which is 1 over x, and we're going to leave f, which is x. And this simplifies to ln x plus 1. Then we're going to take the derivative of this. So you take the derivative of x minus 1. This becomes, the derivative of x is 1. The derivative of a constant is 0. So this just becomes 1. So now we can rewrite the numerator as the limit as x approaches 1 to ln x plus 1 minus 1. Okay, then we take the derivative of the bottom. So that's product again. So we're gonna do the derivative of x minus 1 and ln x. So this is our f and this is our g, and the formula goes f prime g plus g prime f, right? So we're going to take the derivative of f, which is 1. We're going to leave g, ln x, okay? And then we're going to add the derivative of g, which is 1 over x, and we're going to leave f. F is x minus 1. So we can write that down. Now, this is ln x plus x minus 1 over x. Perfect. Now, since we applied L'Hospital's rule, next step is we're going to plug in 1. So when you plug in 1, this is 0 plus 1 minus 1, that's 0. Ln x of 1, that's 0, plus 1 minus 1 is 0. 0 over 1 is 0. Remember, you could divide a number into 0, but you can't divide 0 into a number. So this becomes 0 plus 0. So we can apply L'Hospital's rule again. And if you notice, these 1's cancel out. 1 minus 1 is 0. So we just have to take the derivative of ln x. And that's equal to 1 over x. Okay? Then, so that's our numerator. So let's write that down. The limit as x approaches 1 of 1 over x. And we know that's going to be over whatever we get right here. So, ln, we have to take the derivative of ln x plus x minus 1 over x. And I want to simplify this before I take the derivative, because otherwise we'll have to do a quotient and this becomes a bit more difficult. So let's just simplify this or expand it a little bit. ln x plus x minus 1 over x is the same thing as x over x minus 1 over x, right? Because if you just combine these, it's x minus 1 over the same denominator. So let's write that. Well, x over x is the same thing as 1 minus 1 over x. So now we take the derivative. Derivative of ln x is 1 over x plus the derivative of a constant is 0 minus the derivative of 1 over x. Well, that's the same thing as x to the negative 1. So you bring down the exponent and you minus 1. So this becomes negative x minus 2. So a minus and a minus become a positive. So this becomes positive x to the negative 2. So let's write that down. So this becomes 1 over x plus 0, so we'll leave that out, plus now x to the negative 2 is the same thing as 1 over x squared. Now let's see what happens. So when you plug in our limit, it's going to be 1 over 1, which is 1. And 1 over 1 is 1. 1 over 1 squared is still 1. So 1 plus 1 is 2. So this becomes 1/2. So the limit as x approaches 1 of this function x over x minus 1 minus 1 over ln x is equal to 1/2. And there you have it. Hopefully that wasn't too difficult.